Okay, so up here you can see our print for the X and then our Y down here. So after we split data into training and testing data, so X, Y train, result Y, X, Y, and then random state, which is equal to 2. So the random state is like an identification number. So, and we print X dot shape and then X test dot shape. Yeah, so next we have to put in the function to calculate the mean squared error. So the mean squared error is a statistical measure that measures the average of the square of the errors between the estimated values and the actual values. So it is always a positive value that decreases as the error approaches 0. So def predicted values so we return and all star raised to the power 2 then the predicted value and then we return and regressor. I put the regressor equal to XGB regressor and then regressor comma a Y train. So everything is ready. So now we do our evaluation and prediction on training data. So training data prediction regressor predict, and we predict our X train now. The R square value is good for checking the performance of our value, so we do an R square train which is equal to metrics R square score R square the R2 train sorry, there's an error here. So the R2 train metrics R2, oh sorry, there's an underscore here. Good. So now our R squared value which is 0.8441. So that is, so if it is closer to 1, then it is a good model. So 0.844, which is getting closer to 1, so meaning this is good. So our next step is to predict for the testing data. So test data prediction equals regressor dot predict the x test r squared underscore tests, the metrics for the y tests r squared for tests r squared score underscore test. Okay, so this is 0.5, so it's in between. Then we calculate the mean squared error. Mean squared error for the train equals calculate y is called train mean squared forest equals the RF training data RF MSE train equals metrics, the mean squared so we put in the print R square value underscore R2 train is the mean squared error. The mean absolute So with the lasso regression, we put in lasso regressor or to lasso and an alpha, which is a default value of 0.05. So the alpha is a penalty parameter that controls the amount of shrinkage applied to the coefficients of the lasso regression. So a higher alpha means that more shrinkage and sparsity, whilst a low alpha means that a less shrinkage and more complexity. So an alpha which is equal to 0 is equivalently to an ordinary least square. So that is why we have the 0.05 here. Lasso regressor dot fit x underscore train, which is train data prediction. And then the next is the mean absolute error for the train, the metrics, that mean absolute square for the training data. So the lasso absolute mean square we change this to the absolute error. Now until we do that of the test. So we replicate this and make changes to our variable. Change this to test. Change your test. Looks good. So now we can run. So we have 1412537. So we can compare it with this. And thank you very much for your time.